Welcome to a video tutorial on scientific notation. You'll definitely want to have your calculator with you to practice what we're working on. So I am going to use the TI 30X2S calculator. So if you don't have this calculator, that's fine. It's just that your keystrokes and the button sequence may be a little different. So for scientific notation, because in chemistry we work with very small numbers and very large numbers, we often want to put them so there'll be some value, a coefficient, and then that will be multiplied by the exponential term. So now this coefficient, it's going to be a number between 1 and 10. So there will always be one digit to the left of the decimal, and then the number of digits to the right will depend on the sig figs. So if you are unsure on sig figs, there is a separate video tutorial that will review sig figs for you to help you. And then of course we have the exponential term. Okay, so exponents. So exponents are a prerequisite of chemistry classes and working with them. So I'll give a very brief review just to jog your memory. If you need more, you're going to want to seek help at the math lab, or sometimes the appendix in your textbook will have some extra information. So remembering that when we have a positive exponent, we can think of this as being a large number. So for example, if we had 10 to the third, that's 10 times 10 times 10, right? 10 multiplied by itself 3 times, or 1,000. When the exponential term is a negative number or less than 1, then we are going to have very small numbers. So for example, if we have 10 to the minus 3, we can rewrite that 1 over 10 to the third, which is 1 over 10 times 10 times 10, which is 1 over 1,000, or 0.001. Alrighty. So now let's get to working with numbers in scientific notation with our calculator. So you want to have your calculator out and ready, because it's really important. You want to be able to toggle back and forth between decimal notation, which the calculator calls flow, and then scientific notation. Sometimes we'll want to work with numbers in their traditional format and sometimes in scientific notation. So for the HP calculator that I gave you the model for, what we want to do is, let's say I enter, 35,000. Okay, so here's this value. Oops, clear that out. Let's do 35,000. Alrighty. Now, if I want this to be in regular floating notation, we go second function, and then where it says Sci Engineering, I can toggle to flow. And I say, yes, that's what I want. So now we see that the number is displayed in decimal, normal, floating notation. Let's say I want to toggle to scientific. We go back to the second function, and then Sci Engineering. We use the arrow keys to go over to the Sci mode and press enter. And now notice that the number is written in scientific notation. There's only one thing that the calculator can't do for you. It doesn't know about sig figs. So remember, when we're doing scientific notation, right, that the coefficient has the sig figs times the exponent. So this is where the human still has to come into play. The calculator won't be able to help you there. Now we know how to toggle back and forth. Let's look at how we could actually enter a number in scientific notation. So I'll clear the display, and so let's say we wanted to enter the number 6.02 times 10 to the 23rd. All right? So we enter our coefficient, 6.02. And now it's very important for calculations, we want to link this all together. This is one number. This is one measurement, one value. So it's important that we link them. So the way we can do that in our calculator is we can take advantage of the enter exponent button there, EE. So once again, we need the second function. We're going to enter the exponent, and then the exponent is 23. So then we can see here's the value in scientific notation. So let me draw some, I'm going to slide this over to the other side. All right, so if we use the second function, and then the button says x minus 1, but it has EE on the top. And so when we push these two keys together, that gives us the times and the 10. So the part that we enter is we enter the coefficient and we enter the exponent, and then the times 10 is through the second function EE key. And this is very important because it's going to help you avoid calculation errors. If you use a different set of keystrokes and you find that you're always off by a factor of 10 on your calculations, or your final result has the opposite sign for the exponent, then it means that you're having a calc error because you're not using your calculator the way it was engineered. Alrighty, so now let's practice this. So let's convert the following numbers from decimal to scientific notation or vice versa. So we'll clear out the calculator. 3.5, enter exponent. Now for the negative here, this minus 3, we want to use the minus button here, minus 3, enter. Okay, so it's still in scientific notation. Sure, the best visibility. Let's try it over there. Okay, so now we want to practice toggling back and forth. Second function, sci engineering. Let's put it into floating. There we go. So 0.0035. Now comes the part where the calculator can't help us with sig figs. Notice in this number, how many sig figs are there? There are 4. So when we write it in decimal or floating notation, remember leading zeros never count. So we would need to add these 2 trailing zeros so that we preserve the sig figs of the value. Alrighty. So now let's practice the next one. 238,000. We enter it. Oh, we're in flow or decimal mode. We'll go back and toggle to scientific notation, and now we have the value in scientific notation, 10 to the 5th. All right, so now we can practice entering another number with our exponent, our entering exponent key, 2.021, second function, enter the exponent, 5. Oh, okay, we've entered it, but it's still in scientific notation. Second function, go back to flow, and now we have it in decimal or floating notation. And we'll make sure, right, we won't put the decimal point because we want to maintain the sig figs. So if we're converting between floating mode or decimal mode and scientific notation, that never changes the sig figs. They should always be the same. And now for this last one, 0.000167, we enter that. We want to change it to scientific notation, second function psi, and enter. There we go, and both results, both values are 3 sig figs. Alrighty, so these are some important buttons that you want to get comfortable using, switching back and forth and being able to enter numbers in scientific notation. And now let's practice doing some calculations. Alrighty, so we'll just use some generic scientific notation terms. So if we have A to the 10 times 10 to the x multiplied by B times 10 to the y, when we're multiplying terms in scientific notation, we multiply the coefficients and then we add the exponential terms. And then in a similar way, if we are using division, we divide the exponents, we divide the coefficients and we subtract the exponents. So I want you to use your calculators and be comfortable using your calculators. But it can be very helpful to be able to do a ballpark calculation in your mind so you can recognize if you have a calc error. Because many times I see that students have a correct setup, but they have a calculation error problem. So there's one last thing to be aware of, is that our calculators are programmed to follow the order of operations. So the order of operations is PEMDAS. So remember that anything in parentheses will be performed first, and then exponents, then multiplication and division, and last but not least, addition and subtraction. And so this is why the order of operations is why it's so important to use your exponent key when you're entering numbers in scientific notation, because otherwise the order of operations can create a calc error even if you have the correct setup. So I'd like to do a quick test right now to see how comfortable you are with your calculator. So I'm going to write a very simple, 25 divided by 5 times 5. Now I know we could all do this in our head very simply and get the answer, but I want to, this is a quick test of your calculation skills. So go ahead and enter this calculation into your calculator the way you normally would and see what results you get. Ideally, you should be getting a value of 1. Because this is 25 divided by 25, which is 1. However, it's possible that some of you may have got the wrong answer. If you got an answer of 25, which is wrong, then you have just been bit by the PEMDAS bug. So when we're doing calculations, it's important to recognize all terms in the denominator are divided. All terms in the numerator are multiplied. So the keystrokes to get the correct answer are 25 divided by 5, and then at this point I encourage you to put an equals or an enter to perform this calculation. And then this second 5, it's true these are multiplied together, but they're in the denominator. So for the overall expression, they need to be divided by 5, which gives us the correct answer of 1. Some of you may be wondering, what did I do wrong here? How did I get 25? Well, if we did 25 divided by 5, but then we multiply by 5, you could see the problem here. Right? 25 divided by 5 is 5 times 5 gets us the wrong answer. So there are several ways to fix this. If your calculator has parentheses, make sure to put parentheses around your denominator terms, using equals to execute. so that we don't build up on our order of operations. And just keeping in mind that all terms in the denominator are divided. Alrighty, so now we've got, we have a couple practice problems here for you to build confidence and being comfortable with your calculator. So go ahead if you want and pause the video for a minute and do the calculations, and then we can compare answers. So, for the video, I'll just go ahead and do the keystrokes on here to help you build your skills. So let's put that there, I think. Alrighty. So we would enter the first number, 2.34. We don't have to worry about the 0. Enter exponent minus 3. Multiply 2.6. Enter exponent 6 equals. And so now we get the result, 6.084 times 10 to the third. And the last thing is the calculator can't help us with sig figs. So I'm going to slide this out of the way. So last but not least then, we're going to consider these numbers as measurements. And so we have 4 sig figs and 2 sig figs. So our final result should be 2 sig figs. So we would report 6.1 times 10 to the third. Okay, now this one, because everything was in the numerator, you can use bad technique and still get the correct answer. So let's try a more challenging calculation like the one below. Alrighty, so here's our numerator term, 3.506. Enter the exponent, 3. Now we're going into the denominator, so everything in the denominator gets divided. Divided by 5.7, enter exponent, 7. And I'm just going to go ahead and execute that so that I don't worry about PEMDAS. And now we're going to divide again because this term is also in the denominator. Divided by 2.61, enter exponent, minus 2 equals. Alrighty, so we get our calculator spits out a nice big number for us. 7 times 10 to the minus 3. Slide this out of the way. Now, last but not least, let's look at sig figs. So this top value was 4, 2, and 3 sig figs. So the worst data limits our result. So we would report this as 2.4 times 10 to the minus 3. Okay, and let's do one more practice to make sure that everyone's going to get all of the points they should. It always is sad to see a perfect setup with a calc error. So let's get rid of those. Alrighty, 7.4, enter the exponent, oops, don't know why I did that, minus 2. Every term in the denominator is divided, 3.248, exponent 6. We'll go ahead and execute that, enter it. And then we have another term in the denominator, so it also is divided. Enter exponent, minus 3 equals. And we get the value, 3.505 times 10 to the minus 6. So now we can check for our sig figs. 2 sig figs up here, 4 and 3. So our final result will be reported to 2 significant figures. And so that would be 3.5 times 10 to the minus 6. Alrighty, so That concludes the overview of scientific notation with practice using our calculator and performing calculations. So go ahead and take some time now to work a few practice problems to reinforce your understanding.